everybody, it's Tyler here at Kettering 1, checking in with 2137, the Oxford Robocats. Just played their first match and had a phenomenal performance so far, so we can't wait to dive more into what this robot has. This team last year, Winners Impact Awards at Troy 2, looking for big things here in REEFSCAPE. Overall, very clean robot as we'll go through on this. We'll be talking about how they're acquiring the coral, scoring that, all within this mechanism. Very reliable climber as well too, and they'll be diving more into a couple things on how they're mounting their CANbus modules, and also be going into programming with Choreo and Embedded Scope and more. So let's learn more about this team coming up here on Behind the Bumpers. This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. Cut is a premier metal cutting service for first teams. No minimum order, options for same-day turnaround, guaranteed lead times, and instant online quotes. Cut is offering first teams 50% off any future order up to $200 when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. Just upload a 3D model or flat pattern to get started. Build your alliance with so many other FRC alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/FRC to learn more about their incredible programs and to get more information. Let's start off talking about your elevator design. How did it all come together for your team, and walk us through some of the great mechanical features of this robot?
Yeah, so our elevator starts down at the bottom where we have two Kraken X60s. Those are powering the spool at a 3-to-1 ratio. And then we have a custom rope routing system in the back that's all covered by our sponsor board, and that pulls the elevator up with continuous rigging. And then for our end effector, we can intake coral through this funnel, and then once it gets in here, we have these rollers at the end that can stop it, and then once we're ready to score, we can start outtaking. For removing algae from the reef, we also have this arm where we can flip it out, and then it's belted to our end effector, and so we only need one motor, and we can have a reel at the end that can pull the algae off.
And you guys were just really effective doing that in your first match as well too. Can we see what a piece of coral looks like coming into your robot?
Yeah.
So what are maybe some other iterations or designs your team went through designing this season?
Yeah, so this is pretty similar to our initial design we had at the start of the season. We had some iteration with our elevator here, down at the bottom with how we routed the ropes. We found that it was causing a lot of issues with friction and eating through some of the 3D prints we had, but that's been fine on the Compot. And then the end effector hasn't really changed much. It stayed pretty consistent throughout the whole season. The only thing is we added this algae stick for the Compot so that we could remove algae from the reef.
Hey, let's talk more about your climber here. I see the winch on it. You were able to get the decline in your first match. Walk me through what you got.
Yeah, so for the climber, we have a Neo on a 64-to-1 stage of max planetary, and that's powering this spool. And we have a spring here, so can you power the climber? So when we turn the spool, it springs out, and then we can get in the deep cage. Basically, we drive in, the cage goes here, and then we hook onto the back of it, and we can pull all the way in.
And what's the timing look like for that? How long are you taking to line up and get that climb?
Right now, we don't have a funnel to align with, but we're still pretty fast at aligning. And then once we're actually aligned, the climb is pretty quick because this can go pretty fast.
Anything else mechanically you want to highlight on this robot?
I think this double-sided belt system is really cool. We saw a lot of teams doing something similar last year for their shooter, and decided it would be a lot lighter than having gears, and also it would be less maintenance because we don't have to work with grease or anything on the gears. And it's worked really well so far. We've had to change the tensioning a little bit, but besides that, it's worked really great.
Let's pass over to Noah, talk a little bit more on your electrical system for things and what's going on from that perspective with your CANbus mech on there. So walk me through just how everything's come together for it and what you want to highlight.
Yeah, so one of the systems that we've had in our robot for about 2 years now, we were testing it out 3 years ago, is basically for each of our swerve modules, we have a system for connecting our can in a parallel configuration using the CTRE carnivore that is super robust, and it basically prevents any issues from occurring in our drivetrain. So we use two separate CAN buses. We use one from the Rio that controls everything else in the robot, and we devote the CTRE carnivore to just the drivetrain, the gyroscope, all the really important stuff. And one of the features of the CTRE carnivore is that you can do basically CAN in a parallel configuration, so you can have your main bus going from one module to the next, but then you can have individual devices in a parallel configuration from each of those. And we initially did that using not super great connections. So in 2024, we developed basically a custom PCB, which does the same thing. It just has CAN in and out, and it allows the devices to be connected to the CANbus in a parallel configuration. It's super robust. We didn't have a single drivetrain failure in 2024, and we haven't had any failures in 2025 so far. So here is one of the modules right here. So it's, you know, super simple, and there's no fancy circuitry or anything, just a board, but this little thing helps out so much, and we've had basically no issues with our drivetrain because of it. So
awesome. Let's bring Avery in here to talk about the programming side of things on your robot. So, I mean, watching your first autonomous, pretty solid overall. So walk me through what you're doing for your auto alignment and how a whole match is running for you.
Yeah, so one of the most impactful features we have this year was our auto line system. It's very simple for the drivers to use. Basically how it all starts is they press either left or right bumper on their joysticks, and that'll tell the robot to target either the left or right reef branch. So that's pretty simple. Once it selects a branch, it PIDs the drivetrain to the point that it knows where it's going to. But how it selects the reef branches is a bit more complicated. So we have over here a quick little visualization. So basically what you're seeing here is there's these little white arrows. The white arrows represent pre-generated positions that it creates based on the position of the reef on the field beforehand. It generates those positions a little off to the side because our end effector is off to the left of our robot, but for the most part, it's right in front of each branch. So that's where the robot is going to actually drive to. There's 3 lines on here. The blue represents the driver's joystick vector. So that's the direction they're trying to drive in. And then there's the green and yellow lines that represent the robot's quickest path to the left and right branches, respectively. So what we do is we loop through each of these points, and we calculate the distance from the robot to those points. The ones that are closer are going to be more favorable, so it'll be more likely to pick those when you press the button. However, it also looks at the joystick vector, compares it to the vector between the robot and the branch that it's nearest to, and it determines, is the driver actually trying to go to this branch? Is the driver driving towards that branch? If they're trying to drive to a different branch, it'll add more to the weight value of each position. And that one will be more likely to be picked because the robot is trying to drive towards it. So it takes in both distance and joystick direction to figure out where the robot should go. And then it's just a simple drive to the point.
Well, Oxford Robocats, a very great and impressive match 1 performance. Can't wait to see how you do throughout the rest of Category 1. Thanks for breaking down your robot for us, and we wish you the best of luck throughout the rest of REEFSCAPE season. Thanks a lot. Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Osh Cut is a premier metal cutting service for first teams. No minimum order, options for same-day turnaround, guaranteed lead times, and instant online quotes. Osh Cut is offering first teams 50% off any future order up to $200 when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. Just upload a 3D model or flat pattern to get started. Build your alliance with so many other FIRST alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/first to learn more about their incredible programs and to get more information.